Okay, and good morning to everyone. And that was the Reverend Al Green. And Everything's Okay. That happens to be off of a CD that Starbucks had available a few months back. And Reverend Al Green, Everything's Okay. And what we are doing in our work right now is dealing with interest. And there are two kinds of interest. What you pay with plastic and what you get when you invest money. Now, what we did yesterday was looking at paying with plastic. And I asked you for today to have a page done for me. That was page 163. And in the last hour, in looking at the questions involved here, this was a payoff table. So let's see if I can bring up the camera just a smidge there. Okay, this is essentially the part, let me just try to center that a little bit better there. There we go. Now notice, we started out with a $100 balance, and what I'm going to do is show you some information that was really necessary for this. I'm just going to scroll down the low-tech scroll. This was on a credit card in which you had 16% interest rate. So 16%. Now the question, as we think about that, what are the interest rates in credit cards right now? They're all over the place, right? If you have good credit, a good payoff history, you might get a credit card for down in the 6% range. You may get a 0% on a credit balance that you trade from one card to another for a short period of time. But if you read the print, oftentimes then it goes to a much higher rate, 14%, 16%. And if you're late with payments, it may jump all the way up to what? 21, 24. I've seen them as high as 24%. Good credit cards that you'd like to have may have interest rates down around 5 or 6%. But for most college students, when they are given the opportunity to get a credit card, the interest rate's going to be up around 20%. One of the students, as I mentioned from yesterday, had been sent a Capital One offer, and I think it was 19.8% was going to be the interest rate. So this table was at 16%. And the question that was asked was, how do you take the entries from this table and work with them? So if we look at the first result, this interest of $1.33, this is the interest you're getting charged. And I want you to understand, I rounded off mathematically. Because if you take your $100 and you multiply by 16% and you're paying for that money for 1/12 of a year, so if you'll have your calculator out, you're going to take 100, multiply it times 16% and divide by 12. You're going to get 1.3333, I suspect. Will you check? We'll just leave that on the camera for a moment. So again, 100 times 16, hit your percent key, divide by 12, and you get 1 point with a bunch of threes. Do we agree? If you do, then understand that typically you'd be charged 134. But I'm rounding off as we would in mathematics. So we get this amount here at 101.33. So as I go to the board and we look at what I have here on the screen with the board shot, I've tried to indicate what happens in the first few rows. So let's follow this through. We start with what we just did, and we end up with a balance of 101.33. Now, this table assumes that you're going to pay 10%. The shortcut we did yesterday, to pay 10%, you move the decimal point one place to the left. So you're going to get the decimal where I'm pointing here, $10.13. Again, rounding off mathematically, not what the banks may do. Now that means I'm going to pay $10.13. Okay? Now when I do that and subtract the $10.13 from the 101 This is my new balance. So that's, after I make my payment, I owe $91.20. Let's go back to the document cam. And you can see that balance after the payment at $91.20. So I'll just come over here to the new balance. Now what do I have to do with that $91.20? I multiply it times the 16%, divide by 12 because I'm using the money for 1 month, and we should get 122, and that's what we have here. Now what I wanted you to see in the board that I can't show in the book, we add this interest onto our 91.20 and get what? 92.42. Got it? So what am I going to pay for the month? 9.24. So that's where this number comes from, 9.24. To multiply by 10%, you move one place to the left because 10% is 10 over 100. That's 1 over 10. That's the same as 1 over 10 to the first. When we divide by 10 to the first, we go one place to the left. And so that gave me an 83.18 after I made my payment. Now, what do you then do? Multiply this by the 16%, divide by the 12, and you should get the 111. Do we agree? And if I raise the line on the document cam, there's the calculation as we go to the document cam, and that's where you were asked to continue. So you had to carry through the rest of this table, and when you carried through the rest of this table, what did you find at the end of 12 months? How much did you still owe at the 12th month? Adrian? $33.55. Is there an agreement on that? Have a couple heads going up and down. So you have only paid off 2/3 of what you borrowed, because using the credit card is borrowing the bank's money. So you, in essence, have only paid $67 roughly in those 12 months, and you still owe $33. Now, what's the big problem? You still have the credit card. And what is it tempting to do? Use it. And so you put more money on it, and the interest gets higher. And if you're good about paying off your bill, they will do what to the amount they allow you to charge? Make it higher. And it can get up $5,000. And if you owe the 5, then your interest is much more. So you were supposed to carry through this as a calculation for a payoff table. Now there's another side to the coin, and it's depressing right now. You have a choice. You can go ahead and use a credit card, or you can put money in the bank and save it, anticipating that you'll do what? Get enough money to go out and buy something. Now this is a real dilemma, because if I put money in the bank and save it, what kind of interest does the bank give me on a savings account? What are the numbers that are kicked around? Just a typical savings account. You aren't putting it in money market. You aren't putting it in long-term certificates, and you don't promise to leave it there for 4 years. What percent? 2 to 2.5, maybe 3? Let's be generous. Let's say 3. The bank is charging you how much for the credit card? Maybe 18%, but they're only going to give you 3% if you save the money. Get the idea? So at 3% interest, you aren't making a whole lot. So the question is, how do we do the problem where the bank's going to give me interest for 1 year? So I'm going to invest $100. Remember, I charged $100. Now I'm going to invest $100. And there's another cliche. How do you make money best? When you are rich. If you have millions of dollars you can invest, your interest is a lot. If you have $100 to invest, it's depressing. Okay? Yes, the old phrase, the rich get richer and the poor get poor. The rich who have hundreds and hundreds of $1,000s to invest can get enough interest they can live off the interest and still have the money in the bank. So let's see how things are for those of us who have $100 in the bank. And that's, for most of us, it's hard to get much above $1,000 in savings. Typically, that life is just expensive to live these days. So let's look at what we have on the board. And I have up here a 1-year interest on $100. Now, this is called annual interest. This is the kind of thing that if you borrowed $100 from your uncle and you said, I'll pay you 6%, folks, we haven't seen 6% on interest rates for bank accounts. Oh, it's been a long time. The argument used to be that 6 was sexy. 6 just had a nice sound to it, but 3% is about what we get these days. But let's say you just put $100 in the bank, 6% interest for 1 year, and they paid you interest at the end of the year. That's it. Annual interest. You get $6. That'll pay for what? Lunch? Well, 2 gallons of gas, or a lot of tacos at Taco Bell, or maybe the Big Mac, shake, hamburger, fries. Okay, 12 tacos for $6. You can feed your family for the interest for the year. Okay? 1 child maybe if it's a oldest, okay. But you get the idea you aren't making a lot of money. Now, understand that if I have 100,000, I can move the decimal 3 places over, and I'll have $6,000. So 100,000 gets you 6,000, but $100 gets you $6. And what is our interest at the bank right now? Not 6, 3. So you get $3. Now you can just get 1 gallon of gas on your interest. Now, who does this problem hit the hardest? Not really. It's the very, very young and the very, very old. Because the very, very old are trying to live on the interest they're getting off the money they saved as they worked. They invest that money, they get interest, and they try to live off of it. So if you have $100,000 in the bank and you get 6% interest once a year, and this is the kind of thing you might get with a CD, certificate of deposit, maybe a good money market account, you might get for $100,000 invested, $6,000 for the year. Okay, that's $500 a month you're living on. So you go someplace where the weather's nice and there are no problems, known as Florida. But what happens in Florida all too often? Hurricanes. Okay, so there's the downside of that. Even though the weather's nice, the hurricane comes, wipes out everything you have, and you're still in bad shape. 100,000 may seem like a lot of money, but if you're only getting 6% once a year, 6,000 isn't a lot to live on. Okay? For a whole year. That's your interest for the year. For 100,000. Now you think, okay, I know the problem is I'm only getting interest once a year. What if I could compound the interest, and I'm going to move over here, quarterly, 4 times a year? Okay? Now the idea is this is going to improve things a lot. So what we're going to do, and I want you just to follow along with your calculator and see if you agree with these steps. We're going to slide over, I guess, Marcella, just pan a little bit to the right so I can just get to this first column. So if you can just pan over that much, there we go. And I'll just move over here and we'll talk about this. So you're going to put, and forget this formula at the top. That's, I'll tell you what it is. That's how much money if you compound every second of the day. Continuous compounding, you get 18 more cents. We'll come back to that. That's depressing. That's the way the banks will typically calculate your interest. But let's do quarterly. That means I do it 4 times a year. So let's look at what we have here. We take our $100, we multiply by our 6%, which is a very generous figure from your bank, and I'm going to divide by 4 because I'm doing it 4 times a year. So my interest for the first 3 months, $1.50. Now you need to understand something. If you take your money out of the bank before the 3 months, nada. You have to leave it. The end of 3 months, start the next day, they give you the interest on quarterly compounding. You now have $101.50. So I add my interest to my 100, right? That's what I'm doing. So now I have $101.50. I'm getting rich. Sort of. Okay, what do I do with the 101.5? Multiply it by 6%, divide by 4, and I've actually gained 2 pennies at 152. Add these together. Are you doing it and getting the 103.02? We okay? So at the end of 6 months, I now have $3.02 I can take out. That buys the tank of gas. I guess the gas has gone down much. You can get a tank and a half now. But during the summer, that wouldn't even buy you a tank of gas, let alone a gallon of gas. So I get a gallon. Now, if you have a motor scooter, 1 gallon fills the tank. Fill it up. Okay, let's slide over, Marcella, a little bit more. And when I move over here, notice I now have $103.02. I'm going to multiply it by 0.06, divide by 4, and now I get an extra nickel. 1.55. Do we agree? Add it in, and are you now at 104.57? You got the idea? So now we have $4.57 that I can take out just at the end of September. Now I have October, November, and December. If I leave it in 3 more months, I start with my 104.57, multiply by my 6%. If you have a percent key in your calculator, you don't have to move the decimal. And then divide by 4 because it's 4 times a year. And I'm up to what? $1.56. And my new balance, $106.13. So how much did I gain doing this 4 times a year? No, I gained 13 cents. I was going to get $6 if I just did it once a year. So doing it 4 times a year, I gained 13 cents. Now, somebody asked in the last hour, what can you do with 13 cents these days? For 13 cents, I don't know. If you saw 3 pennies and a dime on the floor, would you pick it up? Maybe. Your kids would, but you might be inclined to 13 cents, particularly if you're in a car and you're stopped at a stoplight and you see 13 cents in the ground, open the door, reach out. Nah, probably not going to happen. Okay. What was the comment back there, Ernie? Okay. If you, I've ridden the bike a lot, and I go by where I'll see 13 pennies lying, 14 pennies lying in the ground. Just ride by. Okay. Put the can of tuna back. Okay, now, in terms of all this, how can we do this in the calculator? That's what I want to come back and show you, a new key in the calculator. Okay, so let's go back to the document cam for a moment. Marcella? Remember, this was a table you're working on, and so you were supposed to finish this up. So what I'm going to do is we come off there. I'm going to go to the calculator, coming off there with me, and let's leave camera 1 where it is for the moment because I may come back there because I'm going to reference it. Here is the calculator, the nondescript generic calculator that I think I paid 99 cents for. So this is my infamous curls calculator. We're going to turn it on. Now, I'm going to put my 100, I hope it came on there. There we go. I got the 0. Didn't press the key hard enough. That's what you get when you pay 99 cents. Okay, there's my 0. I'm going to enter 100. Will you do that now? And do you see the M plus key on your calculator? Now, mine, it's in the 2nd row, 3rd key over. M plus. So I'm going to press that key, and what that does is open up a memory. M for memory. M for millions, M for millennium, and M for memory. And M for 1,000 in the Roman system. So depending on how you see M. Now I'm going to multiply by, so there's my multiplication, times my, now what did we have? 6%, right? So I'm going to hit 6, and I'm going to hit the percent key, and then I'm going to divide by 4, and then hit the equals key. There's my $1.50. Now I'm going to add that into my $100. So I want you to hit the M plus. And now MRC stands for memory recall. And there's my 101.50. You should have an MRC on your calculator. MR is memory recall. Okay, I have an MRC, you have an MR. Memory recall. Now, what are we going to do? Multiply by 6%, divide by 4, hit an equal sign. Now there's my 152. Let's come back to the board, and right here, Marcella, is where I want to hit the one. Whoa, there's my 152. So I'll just rotate. This is my 152 we're getting in the calculator. Now back to the document cam for just a moment. Notice I rounded down to 152. This is the bank's giving. They don't give very easily. Okay, so this is 152 back to the board. That's my interest. And then what do I want to do? Add that in, and I'm just going to use the M plus key. So let's come back to the calculator. We're going to hit the M plus key and add that in. When I do that and hit memory recall, there's my 103.02, and that's what I have right here. You with me? Now, what are we going to do? Multiply that amount by the 6% divided by 4 back to the calculator. So I'm going to multiply this again by 6%, divide by 4, hit the equal sign. I'm going to try to get that so we can read it a little bit better. Let's see if that works better there. Yes, 1.545. And so if I'm going to round off, mathematically, it's what? 155. Now, the bank would technically probably round down. Now, keep in mind, banks aren't doing quarterly compounding very often. So this is not a scenario they carry through. And again, I'll show you what they do. Now, what am I going to do with that 155 as I go back to the document cam? M plus, because I want to do what? Add that back in. So memory plus, and then memory recall. And now I'm up to that grand and glorious sum of 104.57. Back to the document cam. You can see where I rounded up mathematically. Technically, the bank probably at 104.56. One more. What do I do? What do I do next? I have this amount. I multiply by what? Oh, or 6%. So multiply by 6, coming back to the document cam. So there's my 6, my percent key, divide by 4, and then I hit an equals key. And here is my $1.57 that we had. I actually rounded to 156, but back to the document cam, technically it would be 157. And then I'm going to hit M plus, memory recall, and there is my $106.13 if the bank does not give me the 14 cents. Now, that's compounding 4 times a year. Agreed? I could compound more often instead of every 4 or every 3 months for 4 times a year. I could do it annually. I'm sorry, monthly, like I did the credit card. So instead of dividing by 4, I divide by 12. Okay, so I divide by 12 if I were doing compounding on a monthly basis. Now, I have a table for you showing you what happens to that $100 when I do it monthly at 6%. So let's see how things improve. This is page 166. So this is $100 on 166, compounding monthly. So that means 12 times a year. Notice, I get 50 cents the first month. So let's see how we'd set this up in the calculator as we come off there for a moment. Now note, this is what we still had left. I want to get rid of, we come back to the calculator, I want to get rid of that amount, so I'm just going to turn it off and turn it back on. So if I turn it off and then turn it back on, it loses its memory just like I do over the weekend. Okay? So the calculator does not hold its memory very well for this price you're paying. If you want to have a better memory, pay more money. I don't know what the solution is for those of us whose memory is shorter than we'd like. But at this point, let's try the numbers again. 100 times the 6%, but this time we're dividing by what? 12, and it equals, and we get our 50 cents. That's the interest we had. As we come off there for a moment, that's what I have in my table. And as we come back to the table, if I added that into my original 100, I'm at $100.50. Now let's just see how the interest increases as we go along. I'm going to slide this up. Let's keep that on the screen for a moment. I'm going to do the low-text scroll. We still haven't made, there we finally made 51 cents for the month. Haven't made, there's 52 cents, not yet. Still not there. I'm half done. Keep going. 52 cents. Finally made 52 cents. Still scrolling. We aren't yet to 53 cents, and I ran out of space. Look how much money I have for the year. 106.16, because they would not round up typically. So at the end of the year I have 106.16. Let's go back to the board again on the amount. How much did I make doing it 4 times a year? 13 cents more than doing it once a year. So back to the document cam, I gained 3 cents doing it monthly. Okay, how are the banks compounding your money as we come back now from there? What do they tell you? How do they compound? Not monthly. Sometimes they say every day. So how would I change the problem if I put my $100 in the bank at 6%? And keep in mind, that 6% is fantasy. They're at 3 typically, or less. But let's do how much interest in that first day. Now remember the pennies on the ground you aren't picking up. You walk by, you see a penny in the ground, and you say, ah, somebody dropped a penny, and you tend not to pick it up. Okay, so with that in mind. Okay, let's take our 100. So I'm going to enter 100. And I'm multiplying it by my 6%, but I get to divide by what? 365. Bingo. And I get a penny. If the bank is going to pay me for that one day, they would pay me 1 cent. So things aren't growing fast. How many times would I have to go through this in the calculator for 1 year? 365 M pluses and MRs to get back to my balance at the end. Now that's compounding daily, 365 times for the year. Now there are some numbers that are very special in mathematics. We've had one of them. Pi. What's pi? 3.14 and garbage to come, right? It's technically 3.14159 and keep going. It doesn't repeat, but it doesn't end. And so the question is, are there other important numbers in mathematics? And the answer is yes. And what I'm going to do is show you another number, and I will put it on the screen here momentarily. Here is the number. It's called e. And that's e to the first. That little arrow on the e means e to the first. So it's 2.7182812828, and that's terribly misleading because it does not repeat. Even though it looks like the 1828's repeating, it doesn't. This is not a repeating decimal. Now this number is very important. It is called E, and it's involved with population growth. So for example, we say that the population of the world is growing. We talk about the population of Modesto growing, and we say it grows exponentially. This number E is involved. So if we double every 10 years or something, it's a result of what we call exponential growth. Now this number is used to get the amount of money you have in the bank at the end of 1 year. And the formula is a shampoo you can buy. PERT. You've seen it. It's in the green container. Next time you go down the shampoo aisle at your local, wherever you buy shampoo, I'm thinking of places like Walgreens and Walmart and Target and wherever else it is. Okay, let's go to the board, and I want the top of that, Marcella, where you see the formula. This is PERT, P-E-R-T. Now it's P for principal. E is that number. Back to the document, Cam. That's my number E. And then RT is the exponent. Well, back to the board, my interest rate was 0.06 times 1. So what I want is e to the 0.06 power. And you say, wait a minute, how can an exponent be a decimal like that? Because exponents have been like 2's and 3's and -1. But we can have a decimal like this. And this decimal is 0.06. So now I'm going to come back to the calculator. Notice I had e to the first. Let me tell you about this calculator. So we come off there just for a moment, Marcella. I think of calculators that I've had to buy. The calculators I've owned. Wouldn't that be an interesting, boring title? The calculators I've owned. If I go back 30 years ago, the first calculator that I might have purchased, maybe a little bit more than that, to the early 70s, 71, 72, ran $100. Okay? And it was made by Texas Instrument. And you had batteries. And it did what your calculator that I've asked you to use that you can buy for 99 cents. So it's gone from 100 to 99. And that calculator was called the Data Math, did nothing more than your calculator that you're using in here did. A calculator like I'm showing you on the screen at that time ran anywhere from $300 to $500. By the way, a pickup sold for $3,000 instead of $30,000. So if you were paying $100 for a calculator in those days, you could multiply it by 10, it would be $1,000 today. So a $300 calculator would be $3,000 for a calculator. I can't picture you running down to the store and buying a $3,000 calculator. You can buy what for $3,000? A very nice computer, right? Very nice. Now, I'm going to, this calculator, by the way, that I'm using as I'm going to show you, is called the Sharp calculator. And they really screwed up the logo here as we go to the document cam. You can barely read the Sharp, and if you get right over it in the right kind of light, you can find that it's an EL531. It's in the bookstore. Price? $11. Amazing. This calculator is awesome for $11. We use it in the stat class. Now, on this calculator, as I look at the keys, and I'm going to drop this down a little bit tighter, this looks like you can play games with it, right? Because you have the little toggle key things here, go right, left, and so on. But you see the e to the x right there in gold? So if I press this gold key, or orange, and then press that e to the x, let's see what I get in the screen. I get e to some power. And what power do I want to put in there? 0.06, and I hit equals. And now I'm going to multiply that times 100. So times 100 equals. And there is your money that the bank will give you, compounding continuously every second of the year. You get $6.18. And if I did it quarterly, I got what? Does it come back to the board? $6.13. So I gained a nickel. 5 pennies for compounding what? Every moment of the day. But notice, one calculation, I didn't have to do it 365 times. Pretty good, huh? Now, 18 cents. I gained 5 cents, we said. But what happens if I have that $100,000? What do I do to the decimal? Move it to the right 3 places, and so that extra 5 cents becomes what? $50. So if you have enough money in the bank, those little differences make a difference for you. Okay? That's what we do in compound interest. Now, as we think about that, as I come back center, what do we hope you do instead of just putting $100 in the bank the first of the year? Otherwise, New Year's resolution, I'm going to put money in the bank. So you put in $100. Next month comes. All the bills from Christmas are there? Oh, well, you could take out the 100, or you can say, well, that's it for this year. But typically, what would you be encouraged to do? Invest another 100 each month. And it does get better as the money increases. So this unit is about 2 things. Borrowing money with a credit card, or investing money in a savings account where you get interest. So what kinds of problems do we have that I want you to do? And let's look at what some of the questions are. Because I've shown you how to use the key. Let's look at just the 5th problem. Here is a deposit of $100, and it's getting an annual interest rate. This is number 5, page 169. So an annual interest rate is 6%. That's what we've been doing. And we're going to use the calculator shortcut to do what? Find the new balance for the 2nd and 3rd month. So what are you going to do for this problem? You're going to use your calculator with the M plus key, the MR key, and just carry through the keys on your calculator to get your balance at the 2nd and 3rd month. We just went through that. We just did that problem. And this was what? If we're getting compound monthly interest, so when we divide it by 12, it is, as we come off there for a moment, what? Come off there for a moment, please. And then what we see, you should be getting these entries in the table that we just talked about for the 2nd and 3rd month. So you're going to show how you did that with what? The calculator to get these 2 entries. Okay, so that was question 5. Question 6. Now that was 5. Question 6. I decided to up the ante. Compound interest table, and here's the issue. We're not going to put $100 in the bank. We're going to get what? A little bit greedy. We're going to put $10,000 in the bank, and instead of getting a 6% interest rate, we're going to do a 8% interest rate. And we're going to do it what? 4 times. And so you're basically going to go through and do what I've done on the board, but now you have $10,000 at an 8% rate. And by the way, that is very optimistic on my part. I don't know of any bank right now that's going to give you 8%. Where are you typically going to have to go to get those kinds of figures? stock returns, stock market, might get it there. In certain investments, you might get somebody who's really generous and give you 8%, but not likely. But that's problem 6. Then let's go to, by the way, here is the problem using your calculator. This was doing on page 173. This is using the M+ key, and you can follow this along. Basically what I did here is I took my interest rate at 8% and divided by 4 because I'm doing it what? Quarterly. And I added 1 to get something I can do in the calculator. I haven't talked about that yet, so we'll leave that alone. But what you've done in the calculator, you should be able to go to the next problem without any difficulty. This is problem 8. Now here's a little table just before 8. Let's look at this. This is on page 174. If you're compounding quarterly, you do it 4 times a year, correct? And if you're compounding monthly, you do it 12 times a year. And if you're doing it daily, 365, although the old banker's rule was 360. 12 months, 30 days. And in problem 8, I just ask you, if you're going to put money in the bank and you're going to leave it in there for 5 years and you compound semi-annually, how many times do you have to carry this through to get your money at the end of the 5 years? So if you think of that, you're doing it semi-annually, so you're doing it how many times a year? Twice, and you do it for 5 years? You've got to do it 10, right? Not a very hard problem. Let's go to problem 9. Now we're going to use the calculator, and the shortcut is the one that I have been doing with the M+ key, the one I just showed you, not the one I've written about here. Let's just use the one I showed you. You're going to start with that 10,000, and you're going to do it what? Semi-annually, twice a year, 8%, and get me the amount of money at the end of 5 years. So you have to do it 10 times, doing what we did in the calculator. Now remember, if I'm going to use the calculator, how do I get rid of everything? Turn it off and then back on. Now the more expensive calculators have a memory that holds if you turn it off and turn it back on. But the one you're using typically will just lose everything when you turn it off. Folks, that basically brings you to the simple interest test. So back to page 175. So you should be, by tomorrow, done with everything up to 175. Now on 175, let's look at the problems here just so you have an idea. And you should be able to go through many of these. Find the first month's interest, the amount owed, and the 10% minimum payment, $75 purchase, interest rate 19.5. No, you just find the first month's interest, just the first line. Then, coming off there, I'm going to go to the second problem. Write your first 3 months of a payoff table, 12% interest rate. Now that APR means annual percentage rate. So that's 12%. And we're going to make monthly payments. You make three lines of your payoff table. Okay, coming off there. Number 3. Now this is a case where we're going to put money in the bank, and you're going to get the first month's interest and balance. You put in 1,000, and the annual interest rate is 4.5%. I don't know if you'll find a bank doing that well, but you might. Then, coming off that, a compound interest table in the next, in which it's $5,000 at 6% quarterly. We did 100, you're going to do it for 5,000. And then, as we come off there, on the 5th problem, we're going to do this quarterly, and we have how much money invested? $2,500. And notice the interest rate, 5.25%, and you're going to do it quarterly for 3 years, so that means 12 lines. So you're going to just write it out for the 12 compounding periods. You should be able to do up through page 175 by tomorrow. Tomorrow we're going to answer questions with that. And then what we will do, I want to see what I have for the supplementary. The supplementary problems are just some questions. There are 10 questions there. We may try answering those in class tomorrow. They are on page 181, and it says the following. These questions should be discussed in a study group. You should be able to answer the questions from this unit. And if you can't, then you're supposed to ask me to help explain what's going on. So you have 10 questions. So I guess it might be reasonable to say, try to do the problems in the unit, spend some time on those questions, and we will do a lot of Q&A tomorrow. Then my goal on Thursday is to have the exam on this unit. You better get a calculator that you can use because you'll be toast if you don't have a calculator that you can do in these kinds of problems. Now, let me think if there's anything else I want to do here. If we look at the idea of a compounding rate. Now, what I want to do here, Marcella, in just a few minutes I have left, I'm going to go to the sideboard with camera 2. So if you can bring that over there, and we'll spend the last couple minutes on an idea I haven't said too much about. And it comes out of algebra. So I want to talk about it briefly. Okay, if you got that, pretty much where I can walk over there. So if you do, just take the camera shot to there, transfer there, and I'll walk over to where the picture is. So I need to have you bring in that shot. Okay, so there we go. Now, this compounding rate is what I'm talking about here. If I look at 6%, so I'm talking about this 6%, and I'm going to do it 12 times a year. Remember we multiplied by 0.06 and divided by what? 12. Well, that becomes this 0.05. So let's slide over now. That 0.005, because this is dividing by 12, so this becomes 12 times a year. Do you recognize this? You should. That's your 0.5% we had in lesson 18, and we've used it before. So this compounding rate is the 0.005. And so the argument I make is if I take this compounding rate and add it to 1, will you do this for me on your calculator? Multiply 100 times that number. And what do you get? $100.50. Right? That was your new balance at the end of what? The first month. Now multiply that by 1.005 again, and what do you get? So I'm going to multiply by 1.005 again, and what do you have? 101? Exactly? So 0, if you're going to do it a third time, times 1.005, and what do you get? 101.50, and this is a nice shortcut that we're talking about in the unit for how you can take your compounding rate, add it to 1, and get your new balance every time. It's a shortcut.